Hello students, good morning. Let us study second chemical property of ethers. Okay. Yesterday you learned that ethers are least reactive among all organic compounds. But they are having some chemical properties also. First chemical property was cleavage by acids. Yesterday, you learned that acids like HCl, HBr, HI, they can react with ethers and cleavage of oxygen to alkyl bond, CO bond, takes place. If ethers are symmetrical, then only one product is formed. But if ethers are unsymmetrical, if ethers are mixed, means both the alkyl groups are different, then the point of cleavage depends. It depends upon some factors. We learned that if one of the alkyl is methyl, then halogen goes to methyl. But if one of the alkyl is a tertiary alkyl radical, then methyl is ignored and halogen goes to tertiary. And if there is benzene ring, then phenol is always formed as a product. And what is the logic behind these 3 points that we explained yesterday? You can view the recorded lecture again to enhance your understanding. Now let us take second chemical property of ether, and that is electrophilic substitution reaction. Electrophilic substitutions. Nothing new in these reactions. We have already learned electro substitutions in benzene, in aryl halides, and in phenols also. 3 times we have studied. So one more time, let us study this. So, ether, when there is a benzene ring, it becomes aromatic ether. The simplest aromatic ether is methoxybenzene. Common name is anisole. So this anisole molecule, the most common aromatic ether, will show resonance. This lone pair of electrons will spread here in the form of bond pair, and the structure will get modified like this. This bond pair will have to move on this ortho carbon in the form of lone pair, because valency of carbon is 4. It was a double bond, single bond, single bond. 4 satisfied. If this lone pair comes here and forms a bond, then valency will become 5. That is not possible. So this bond pair will have to go on this ortho carbon in the form of lone pair, and obviously this carbon will get a negative charge also. And this oxygen, because a pair of electrons is going down, which is forming a bond pair. So this oxygen has net loss of 1 electron. So it will get positive charge. Okay. Now, this lone pair will move on this single bond, spread in the form of bond pair, and this structure will now become like this. This is bond, and this bond pair, because this carbon will get a valency of 5, which is not possible, So this bond pair will move here to form a lone pair. This is resonance. Okay. Now this lone pair and this bond pair, they will transform like this. And finally, this structure is formed. We can call it structure A, structure B, structure C, and structure D. Okay. And negative charge is traveling from ortho position to para position, again to ortho position. And meta positions are not getting any negative or either positive charge. Okay. And from this structure, this bond is single, this is also single. So this lone pair on this single bond and this bond pair will go back. Structure D will again transform into structure C, then B, then A. Okay. So this is it. And what is the actual structure of anisole? Actual structure is resonance hybrid of all these four resonating structures. It is having common structure which is called resonance hybrid, and that structure will be like this. This CO bond is single here but double in other three structures, so we make it more than single, less than double. Oxygen in three structures is carrying a positive charge, but in one structure no charge, we put partial positive on oxygen. Okay. And ortho and para positions are having negative charge in structure B, C, and D. So we put partial negative on both ortho and one para position. So this is the actual structure of anisole. But commonly we write its structure like this. But reality is that it is a resonance hybrid of these four structures. You have learned in 11th class also that sometimes all properties of a molecule cannot be explained by drawing one structure. We have to draw two or more structures to explain all the properties. Then these structures are called resonating structures, and this is called resonance hybrid. Okay, so this is actual structure of anisole. Keep it in mind, and you understood that ortho and para positions are having negative charge, meta position is having no charge. So when electrophile is going to attack this ether anisole molecule, which will be the better site for its attack? Of course, it will be ortho and para. Okay, because electrophile is electron seeker, negative seeker. So for electrophile to get attached to attack, the better position is ortho and para. Okay, now let us study its reactions. First example of this kind of reaction is halogenation, means reaction with halogen. Let us take the example of bromine. This is anisole and this is bromine. One more thing keep in mind, we have just learned that lone pair comes down. This methoxy part is sending its electrons towards benzene ring. That means it is activating the benzene ring. Also, negative charge came on ortho and para position. So electrophile will get attached on ortho or para position. So this methoxy group is ortho para director. It is directing the electrophile to get attached to ortho and para position. So you can say that this methoxy group is activating group. It is increasing the reactivity of benzene towards electrophilic substitution reaction. So methoxy group is activating group and ortho para directing group. It is directing electrophile to ortho and para position. Clear? Now, one more thing you must remember, that whenever we carry out a halogenation reaction, if we carry it with chlorine, we need FeCl3 catalyst. If with bromine, we need FeBr3 catalyst. Okay. And here, because this methoxy group is activating group, it has increased the reactivity of this benzene ring. So no FeBr3 catalyst is required even. The reaction takes place in presence of ethanoic acid. Okay. So you can even skip FeBr3 here in this case. And the reaction goes like this. One of the H atom from ortho or para position is replaced by Br. This is electrophilic substitution. The H which comes from here gets other Br minus HBr. Similarly, the reaction can take place at para position also. And the product is ortho-bromoanisole. This is para-bromoanisole. And para-bromoanisole is the major product. Why major? Because there is less steering hindrance. It is having steric hindrance, both are very close to each other, offering repulsion to each other. These are maximum away. So due to minimum steric hindrance, para product is always major product. It is about 90%. Okay. So this is first example, halogenation. Now let us take second reaction. Second reaction is nitration. Anisole, let us treat anisole with nitric acid, HNO3, and sulfuric acid will act as catalyst. Whenever we have to carry out nitration, we use sulfuric acid as a catalyst, and a mixture of nitric acid and sulfuric acid is called nitrating mixture because it causes nitration. So it is a nitrating mixture. So we are using nitrating mixture with anisole. The reaction takes place like this, that ortho and para position gets substituted with the nitro group. The H gets OH to lose water. Again, the product formed is ortho as well as para, but para is the major product. Para nitroanisole is major product. Okay, so this was the chemistry of nitration. Now let us learn third reaction. Third reaction is Friedel-Crafts alkylation. Friedel-Crafts alkylation. We are treating anisole with haloalkane, CH3Cl for example. Methyl, ethyl, propyl, any alkyl, Cl, Bri, any halide. So we are treating anisole with the alkyl halide, and in these reactions, catalyst is AlCl3. In Friedel-Crafts reactions, catalyst is AlCl3. What happens? Ortho or para position gets substituted by electrophile. Who will be electrophile? Cl is electronegative. Cl will become negative. This CH3C will become positive. It will attack ortho or para position. And H from ortho and para will get Cl. So substitution take place this way, minus HCl or at para position, and this para-methyl anisole will be the major product. Okay, then next reaction, Friedel-Crafts acylation. Substitution with acyl radical. We take a molecule of anisole and put acid chloride, RCOCl. Again, this bond will go towards the Cl due to its high electronegativity, and this part, this carbon will get positive charge. So this is acyl radical. R is alkyl radical, RCO is acyl radical. Again, catalyst is AlCl3, and ortho or para position will get replaced by RCO. This C positive will get attached to carbon of benzene like this. Okay, and para will be the major product. What will be the name of these compounds? See, this is methoxy and this is acetoxy. It has got preference here. So, ortho-methoxy acetophenone. Similarly, para-methoxy acetophenone. So, this major product is para-methoxy acetophenone. Okay. So these were the electrophilic substitution reactions of ethers. We have taken the example of anisole. Okay. So now you have to learn some important applications of ethers. Ethers are very least reactive. So ethers are mostly used in providing inert atmosphere to chemical reactions. For example, you have done Wood's reaction, you have done many reactions of Grignard's reagents. So all these reactions are carried out in ether because in those reactions, water changes the path of reaction. Water is a polar solvent, so we avoid water in these reactions and we use ether at the place of water because ether is inert. Okay. Moreover, ethers and alcohols are mixed together and used just like petrol. These are a substitute, but it is very costly. So it is not very common, but we can use mixture of alcohol and ether. It is called natalite in commercial terms. It is called natalite. Then diethyl ether was earlier used as anesthetic. It was anesthesia. It was used to make a person subconscious for some medical treatment, for some operations. But it has many side effects. So now we have better anesthesia. So we don't use diethyl ether nowadays, but earlier it was also one of its applications. Okay, there may be some more uses you can study from your books. And now we have completely finished Unit 11, alcohols, phenols, and ethers. By today evening, I am going to post an assignment on your Teachment app in homework section that you have to finish in within 2 or 3 days. Okay, and tomorrow we shall start with the next unit, Unit 12. Till then, goodbye. Thank you.